Hello, chemists, and welcome to the next stoichiometry example. This is very similar to the last example, just with a couple twists. Instead of using mass, we're going to be using liters and number of molecules, and we're going to be looking at hydrogen this time instead of ammonia as what we're trying to find information about. But this is another classic example of a stoic problem, just like the last one, where we're going to lay it out in like a similar way, figure out where we're beginning, where we're ending, and then setting up a bunch of conversion factors, plugging in all their numbers, and getting a final value. And that's really how all these stoic problems are going to end up breaking down. You start somewhere, you want to get somewhere, and everything else is just like something you have to do in the middle to get where you're going. Um, Here's our steps once again. They're going to shake. There you go, they shake. We have to make sure this equation is balanced. Number one, every single time, make sure it's balanced. Then we have to look at the problem and see what we know, basically what it gives us and what it's asking for. Then we have to add our conversion factors by mapping it out. Then when we actually plug in our numbers, we're going to put the units we want to cancel on the bottom and the ones we want on the top. You'll see that later on. Then we're going to plug it into our calculators. But first things first, let's bounce this. Pause the video for a second here and give that a go. 3, 2, have you paused it yet? 1. All right. Okay, so here's our balanced equation once again. We have nitrogen gas reacting with 3 hydrogen gases to create 2 ammonia gases for our molar equivalents. All right, so now I want you to figure out what it's giving us and what it wants to find, and try to map out those arrows the same way I did in the last equation, where you map out each step you'll have to do along the way to get where you're going. I'm going to encourage you to pause here and just start this up to the point of actually setting up your equations. Try to work a bit ahead here, and then I'll go over it in 5, 4, 3, have you paused it? 2, 1. Alrighty, so let's read this question very carefully. It says, how many liters of hydrogen gas are needed to react with 7.07 times 10 to the 22 molecules of nitrogen gas at STP? STP means standard temperature and pressure. It's a fancy chemistry way of saying normal conditions. I'll write down the actual constant in a second, but that's the thing that means 22.4 liters of a gas is equal to 1 mole. So here we're being given 7.07 times 10 to the 22 molecules of nitrogen. I'm going to spoil it and say we will have 3 conversion factors, so if you already figured that out, awesome. If not, I'll show you in a sec. And we want volume of hydrogen, and that's liters, so how much space the gas takes up. Here are our arrows. So the big thing here is you'll see a very common thing in all these problems, like I outlined last time, is this mole to mole in the center. This is pretty much going to happen in all the stoic problems you see. Then on either end, we're just doing some extra stuff to get it in or out of mole form. So we get given molecules, we want to go molecules to moles. Then when we have moles, we can go moles to moles to find information about hydrogen. Then once we have moles of hydrogen, we can find our volume. So we're being given information about nitrogen in a weird form that's not moles. So we have to turn it into moles. Then when we have moles of nitrogen, we can get information about the moles of hydrogen, and then we want to turn that into information about the volume. So that's how all these steps break down. I'm going to circle these again because each one of these arrows turns into being a conversion factor, or like one of the fractions that we're going to set up. And again, mole to mole in the middle. Keep a lookout for that because that should happen in each of your problems. Okay, I want you to try to set this up on your own now. Work through the entire thing and get an answer. Then, after you've tried that, unpause this video, and I'm going to go through each step and show you how the units cancel, so you can check your work right away and see how that's going. Because these problems, if you can do this, you can do anything in this unit. Even as we get to limiting reactions and stuff further on, that just adds twists on this general recipe. But this is the meat and bones of stoichiometry, so give this a crack. Anyways, pause the video, and I'll come back in 5, 4, 3, 2. Have you paused it? Good. Okay, 1. So these are our constants. I should have shown that to you before, but I did mention that, and you probably know those by now. So 1 mole is 22.4 liters of a gas at standard temperature and pressure, and 1 mole is also 6.02 times 10 to the 23 molecules, Avogadro's number. So our starting point here is 7.07 times 10 to the 22 molecules of nitrogen gas. Then we want to take this nitrogen gas value and find an amount of moles of nitrogen gas. So we want to cancel molecules. So we have to put units to cancel on the bottom. So we're going to put our number of molecules on the bottom here to cancel it. And then we want to put moles on top. So we want to turn it into moles of nitrogen if you're following along these arrows. So our first step then will look like that. We put 1 mole of nitrogen on top for every 6.02 times 10 to the 23 molecules. Molecules will cancel and we'll be left with moles of nitrogen after this step. Look at that fancy animation. Real high budget stuff. So then we have moles of nitrogen. We want to turn this into moles of hydrogen. Excuse me. So this is a bit of a different case because we're not doing ammonia this time, so the coefficient's going to be different than our last two examples. But again, it's still just coming from the balanced equation. So we know that there's 3 moles of hydrogen for every 1 mole of nitrogen, because the coefficient up here, if you go from here and look up here, so the coefficient here is 3, and the coefficient of nitrogen is 1. So there's 3 times as many moles of hydrogen as nitrogen. And then these moles of nitrogen are going to cancel out like magic. So then we have moles of hydrogen, and we want to find liters of hydrogen. That's just our constant that 22.4 liters is 1 mole at standard temperature and pressure. That's what STP means. So we're going to put that in. Again, our units are going to cancel, and we're going to be left with a volume of hydrogen, which is what it was asking us for, liters of hydrogen gas. So now, I invite you to type this into your calculator, just to make sure, especially if something changed from the first time you did it. But type this in and see what you come up with. Remember, 3 sig figs here. And I'll give you 3 to pause it if you haven't done it. 3, 2, 1, and 7.89 liters of hydrogen. So this question, none of the individual steps are that crazy, but there's a lot of steps and a lot to organize. So that's the big thing with these Stoic problems, is being able to break them down in order and make sense of what you're being given and what you're being asked. If you can do this comfortably, you're in great shape and the rest of the unit will make a lot of sense. And if you can't, don't worry. The only thing that makes these automatic is practice. So go to those practice sheets that are getting posted and try out the problems. And if you get stuck, just look at this video and try to like fill in the blanks with that problems, like variables or equations or whatever. But all these problems are going to break down like this, where you're going from like something to moles, then a mole to mole, then a mole to something. You're going to see a very similar flow to this in essentially all the problems. I wish you the best of luck on your further practice. Once again, you can email me, mrbsciencenb@gmail.com. That'll be posted in the description as well. You can ask any questions or anonymously request a problem to be solved. So yeah, I hope you all have a lovely day, chemists, and yeah, good luck.